Okay, so we're on 2017 FRQ on number 6, and it gives you two different functions here. It says, well, actually 3 different functions. Here you have a table for g of x, here you have a graph for h, and then you have f of x is defined as cosine 2x plus e to the sine x power. Okay, let g be a differentiable function. We have a table here, and it gives g and g prime, and h is a function whose graph consists of 5 line segments, is shown in the figure above. All right, so there are straight lines, which is really nice for us. Okay, find the slope of the tangent to the graph of f at x equals pi. Okay, so again, tangent tells us we need to look for the first derivative, right? And then plug in the x equals pi, and that's your slope. Okay, so f prime equals, don't forget your chain rule. So the derivative cosine is negative sine of 2x. Take the 2 out of the 2x, so put the 2 in the front, okay? Plus e to the sine x, and then the derivative sine x itself is positive cosine x. Okay, now plug in f prime of pi. So negative 2 sine of 2 pi plus e to the sine of pi times cosine of pi. Okay, well, first of all, sine of 2 pi is 0, so that's gone. Very nice. Sine of pi is 0 also, so that's 0, but it's not gone because e to the 0 is 1, cosine of pi is negative 1, so you get a final answer of negative 1. That is your slope at x equals pi. Okay, all right. Part B, let k be the function, let me use this space now, k be the function defined by h of f of x, find k prime of pi. So this is a composite function, we need to use chain rule, right? So k of x equals h of f of x. So k prime of x is equal to h prime of f of x times f prime of x. Right, that's chain rule. So you take that derivative outside, keep the inside, take derivative inside. Now to find k prime of pi, so k prime of pi equals h prime of f of pi, f prime of pi. So first of all, h prime, what's f of pi? So plugging in pi into my f, right? So over here, plug pi. F of pi equals cosine of 2 pi plus e sine of pi. Cosine of 2 pi is 1, e to the 0 is 1, so it's 2. All right, beautiful, that's easy, 2. F prime of pi we got from the previous part. F prime of pi is negative 1. So what is h prime of 2? So what is the derivative of 2? Well, 2 is right here. The slope is down 1, right 3. So negative 1 over 3, negative 1 over 3 times negative 1. So my final answer is 1/3. Okay, all right. Whew. All right, part C, end of exam, not yet. Let m be the function defined by m of x equals g of negative 2x times h of x. Find m prime of 2. So there's chain and product rule here. So m of x equals g of negative 2x times h of x. M prime of x equals, well, the derivative of the first, that will be g prime of negative 2x. Take out the negative 2 because of chain rule. Keep the next one, h of x, plus g of negative 2x and an h prime of x. Okay, so that's your product rule and chain rule there. M prime of 2 equals negative 2 g prime of, oops, I don't want too many parentheses here, that's too confusing. 2 times g prime of negative 4, because I plug in the 2, times h of 2, plus g of negative 4 h prime of 2. Okay, so negative, what is g prime of negative 4? Looking here, g prime of negative 4, my answer is negative 1. So that's times negative 1. H of 2, so the value of 2. So 2, the value is here. What is that value? Well, we know our slope is down 1 over 3. So we know then that value is negative 2/3. All right, so negative 2/3. You can also do that by figuring out the equation and plug in the 2. Same idea. And then g of negative 4, so go back up. G of negative 4 is 5, so 5 here. And what is h prime of 2? We got that from the previous part B. H prime of 2 is negative 1/3. So that will give me negative 4 over 3 minus 5 over 3. That gives me negative 9 over 3, which is negative 3. Beautiful. Okay. All right. Part D, is there a number C in the closed interval between negative 5 and negative 3 such that g prime of C equals negative 4? So remember, we're looking for G prime equaling a number. You know, then this is the MVT, mean value theorem of a derivative, right? So you got to figure out, well, I got to figure out G of -5 and G of -3. So I find the slope to see if it is equal to -4. That way, then there exists such a number that you can have the derivative equal to the instantaneous, to the derivative equal to the slope, right? All right, so let's find G of -5 and G of -3 first. Well, G of -5, looking at our table here, G of -5 is 10, G of -3 is 2. All right, so 10 and 2. So y2 minus y1 over x2 minus x1. So that gives me 8 over -2, -4. So yes, this is the slope, right? So then, because we know that G is continuous, so G of x is continuous based on what it says up there, right? It says G is differentiable. If it's differentiable, it's continuous, right? And so by MVT, there exists a value C such that G prime of C will equal to -4, because you have the slope here equaling to -4, so the derivative will equal to the slope. Okay, all right, that's it.